Today we're going to discuss how we make models or diagrams of atoms. We're going to look at how to make a Bohr diagram or Bohr model. You've seen the general structure of the Bohr model in previous lectures. It's the one with the central nucleus surrounded by the circular electron shells with electrons in it. Now let's learn how to make our own Bohr model using the periodic table of elements and the key associated with it. The key is going to tell us what information is contained in each element box. For the most part, the general structure of the Bohr model is the same. You have protons and neutrons in the center, or the nucleus, surrounded by electrons flying around it in orbitals, or what we call electron shells, or energy levels. Each atom is going to have a specific number of protons in the center that are positive, and neutrons in the center nucleus that have no charge. Remember that each orbital, or energy level, can only hold a certain amount of electrons in them. Remember, the orbitals are labeled by letters. The innermost orbital is the K shell, the L shell, the M shell, and the N shell. In order for an outer level energy level, in this case the N shell would be the outermost energy level, the orbitals beneath it must fill up their shells with electrons. And if you remember, the K shell can hold up to 2 electrons, the L shell can hold up to 8 electrons, the M shell can also hold 8 electrons, and the N shell can hold up to 18 electrons. There are atoms that have up to 7 energy levels, and they're indicated by the elements in each period of the periodic table, meaning the rows that go from left to right. So the atoms or elements that are contained in the first period, or the top row of the periodic table, only have a K shell. The atoms or the elements in the second period or second row only have an L shell. In the third row or third period, only have the M shell. The fourth row or the fourth period have an N shell. And this continues up to the seventh period or seventh row. So the largest atoms we know of only have 7 energy levels. Each one of these rows, or what we call periods, has elements in them. So the atoms in the first period only have 1 energy level. They have the K energy level, or 1 electron shell. In the second period, they have 2 electron shells. In the third period, they have 3 electron shells. Okay, so we know their basic structure. In the first period, we have atoms that have a nucleus surrounded by 1 energy level, or 1 shell. In the second period, we have atoms that have a nucleus surrounded by 2 energy levels, or 2 shells. In the third period, we have atoms with a nucleus surrounded by 3 energy levels, or 3 shells. And in the fourth energy level, we have atoms that have a nucleus surrounded by 4 energy levels, or 4 shells. One thing to remember is that the valence shell, or the outermost shell, cannot be filled with electrons until all the energy levels below it are full. We can use this periodic table and the key on the periodic table to help us construct our Bohr models. Let's go build a couple of these Bohr models using the information in the periodic table. These first 2 elements are contained in the first energy level, so they're only going to have 1 electron shell. Before we start each model, we need to know how many protons and neutrons are in the nucleus and how many electrons are occupying the orbitals. We can get this information from the periodic table of elements and its key. Now up here you'll see that 1 is the atomic number. The atomic mass number of most hydrogen molecules is 1.008, but we're going to round that off to 1 so we can calculate the number of neutrons in our atom. The atomic number here of hydrogen, we said, equals 1, and the atomic mass equals 1. Now we know hydrogen has to have 1 proton because that's its atomic number. Now remember, in order to calculate the neutrons, you have to subtract the atomic number from the atomic mass. So when we do that, the atomic mass minus the atomic number equals 0. So there are no neutrons in this hydrogen atom. Now remember that all the atoms on the periodic table are in their neutral state, unless otherwise noted by a plus or a minus sign next to this element symbol. Since there is no plus or minus sign next to this hydrogen element symbol, we know that there are equal numbers of electrons and protons. So if there's 1 proton, there's 1 electron. Now let's do the same thing with helium. In helium, we have an atomic number of 2. So that means we have 2 protons. We have an atomic mass of 4. So in order to calculate the number of neutrons, we have to subtract the atomic number from the atomic mass. So 4 minus 2 equals 2. So in this particular atom, you'll see you have 2 protons indicated by the atomic number and 2 neutrons because the atomic mass is protons plus neutrons. So if we subtract the 2 protons from the atomic mass, we end up with 2 neutrons. And like we said, all these elements are in their neutral state. So if we have 2 protons, positive protons, we're going to have 2 negative electrons. Let's quickly look at some of the atoms in the second period. We're going to do the first 2 elements in the second period, lithium and beryllium, and the last 2, and try and see if you can see a pattern developing. Here in the lithium atom, we have an atomic number of 3. So we have 3 protons. We have an atomic mass of 7, if we round it off. So 7 minus 3 equals the number of neutrons, which is 4. And since this atom is in its neutral state, we have equal numbers of protons and electrons. So we have 3 electrons because we have 3 protons. So we fill up the innermost shell first with 2 electrons because the K shell can only hold 2. And we put that 3rd electron on the outermost shell, which is the L shell. Let's do the same thing for beryllium. It has an atomic number of 4, so it has 4 protons. It has an atomic mass of 9, so 9 minus 4 equals 5 neutrons. And since it's electrically neutral, we know it has 4 negative electrons to balance out the 4 positive protons. Now you may notice that I skipped elements 5, 6, 7, and 8, but hopefully you can tie in the process in between. Now let's look at the atom fluorine. Fluorine has an atomic number of 9, so it has 9 protons and an atomic mass of 19 if we round 18.99 off. If we round off 18.9, it's 19. So 19 minus 9 equals 10 neutrons. Like we said, this is an electrically neutral atom, so it's going to have 2 negative electrons on the inner K shell, which leaves us 7 remaining electrons to fill in. Now let's look at neon. Neon has an atomic number of 10, so there are 10 protons. An atomic mass of, rounded off to 20. So 20 minus 10 equals 10 neutrons. And because this atom is electrically neutral, once again, it has 10 electrons. So a neon atom has 2 electrons in the innermost shell and 8 in its outermost shell. Hopefully you're getting a sense of how I'm doing this. If you have any questions, please make sure you ask us in class.